2NURFM, a broadcast service of the University of Newcastle.
Time to bring in the good Professor John O'Connor. And John, this week we've got a very interesting point we're talking about, something that was discovered a long time ago by someone more famous than you or I could ever be. Good morning.
Good morning. Yes, I mean, Leonardo da Vinci, he may not have discovered it, but certainly he wrote about it, and probably he discovered he was a meticulous person for observations. But it's actually about trees, and it's something that I've never really thought about. I mean, we know what trees look like. They've got a trunk and they go off into branches and so forth. But he observed that when you fork off into a branch, the cross-section of the two branches, the area, when you add them together, is the cross-section of the branch they've come from. So as it forks out, the cross-sectional area remains constant. So it gets smaller and smaller because you get more and more branches. But you know, there's a conservation there that as it goes up, that area becomes constant. So it means that the amount of timber at any one level away from the trunk is still the same amount of timber. It's just in smaller bits, you know, twigs and so forth. And there's been a lot of, I'm not sure Leonardo had any thoughts about why this happened. He certainly observed it. And it's been found for a large number of trees. There are some approximations there, but certainly a broad range of trees. So there seems to be something fundamental to why this happens. Now, for a long time, people thought it was because of the way water is pulled up through a tree, which is another interesting topic in itself. So that, you know, the water would come up and it would try and remain constant in these branches. And that was really the accepted theory about why the trees branched this way. But more recent research, a couple of groups over the last 3 years have reported doing studies of the mechanical properties of trees. And what they effectively do is they make a model of a tree. Now, engineers and scientists are famous for this because they classically the statement is, you know, let's model a cow. Let's take a spherical cow.
Let's model a cow.
You've got to be careful. So, yeah, some of these models you've got to be very careful about. But the modelling by a number of groups has shown that if you put a leaf at the end of each of these final branches, and of course they're there for a lot of leaves, and then look at the strength of those branches to stress, which would be wind, then the optimum value would be obtained if you actually had this branching ratio. So you could make the branches bigger, which would make them stronger, but that would be unnecessary. You'd be putting energy into making wood that wasn't needed. If you made them thinner, then they become fragile. So that's what I mean by optimal. It's the best use of wood to ensure that you've got the tree growing and the tree withstands the stress put on it by wind blowing.
It's basically having the best possible use of the space, isn't it?
That's right. Well, nature has worked out a way of optimising, which is really interesting because that's what nature does particularly well.
I think the question is, how does it do it? Because it's happening, but it doesn't. The tree, in this case, doesn't sort of have an active brain as such to go, well, this is the best way to do it, but it kind of does in its own way.
Well, it does it by the same process as in natural selection. And the trees that didn't use this method and actually became too thinner would get blown over by storms and they wouldn't survive, whereas those that produced branches that were too thick were putting too much energy into growing these things and probably weren't as viable in difficult circumstances where the soil was poor or where there wasn't a lot of water around. So there's a natural movement towards the optimum solution, and this is a natural selection process occurring over millions or certainly millions of years. And so it's interesting that nature, by this gentle nudging all the time to get the best solution, does get the best solution, and it's one that science sometimes takes a while to explain.
So pretty much it's selecting the best of the best.
Exactly.
Kind of like us this morning. Are we the best of the... No, maybe?
We're not as good as Leonardo.
No, or indeed a tree that can just maximise our space. John, thank you for your time with us as always this morning.
Thank you.
We love him sticking around with us. It's Professor John O'Connor at 2NURFM 103.7.